In this problem, we're looking to find where the streak of light ends up on the floor from this light bulb. So imagine there's no other sources of light in this room, it's just the light, it bounces off the mirror, and it ends up on the floor. So there's going to be some reflection of the light from the light bulb onto the floor. Now let's think about it from the bottom up. The light coming from the light bulb hitting the bottom of the mirror would be reflected directly into the ground, so it's not going to go anywhere. We have to go up the mirror to see the reflection streak spreading across the floor. So if we go to this point right here, that light's going to reflect down here. If we go a little bit higher, the angle is going to be coming in a little bit more shallow. Remember, we measure angles from the perpendicular, so this angle is going to be a little more shallow, so it's going to reflect a little more shallow, and it's going to spread out further. What we can conclude is that the length of the streak is going to be determined by where the light reflects at the top of the mirror. So that's what we need to plot out. The light that's coming from the light bulb and hitting the top of the mirror. So that ray of light. All right, so we have the law of reflection. Like I just said, this is going to depend on the perpendicular. So I'll draw in the perpendicular to this point. And the law of reflection says that this angle here will equal the angle of reflection. And so I'll try to make it look pretty close. Something like that. Okay, so that this angle here matches this angle here. If this is theta, this is also theta. And the reflected beam heads down this way. Okay, so comes from the light bulb, bounces off the mirror, and ends up down here. Any light that hits further down the mirror is going to be reflected onto the floor somewhere in this area. And so the length of the streak is the length from here to the mirror. So let's call that x. So what we need to know is this length. We know this is 2 meters. We know this angle is theta. If we think about the geometry a little bit, this line, the perpendicular to the mirror, is parallel to this line. So this angle has to match this angle. So this is also theta. We're going to be working with triangles here. So we have this angle theta, we have 2 meters here, and we want to know this side. So if we knew what the angle was, we could figure it out. So now let's look at the triangle up here. We have the light bulb to the corner of the wall, or where the walls meet, where the wall meets the ceiling. This line is parallel to this line, so if this is theta, this is also theta. All right, and now on this triangle, we know both sides. We know this is 1 meter, we know this is 0.5 meters. So we have the adjacent side, we have the opposite side, so we can say that the tangent of theta is equal to opposite over adjacent, 0.5 divided by 1.0, or just 0.5. So now we know the angle. We can also do a similar thing down here, and we can say, well, the tangent of theta down here is equal to the opposite, which is 2, divided by the adjacent, which is x. Okay, so again, just relating these two things together, we actually don't need to calculate what the angle is. This tangent theta is the same as this tangent theta. So we can combine the two together and say 0.5 over 1 equals 2 over x. Or rearranging x is equal to 2 over 0.5, which is equal to 4 meters. So it's 4 meters away. X equals 4 meters.